Many architectural structures incorporate a water feature as a prominent visual component of the structure. Some are beautiful fountains with water spraying up to 10 to 20 feet in the air. The particle system in 3ds Max can be used to animate the water in the fountain and create a very realistic presentation of this type of architecture. In order to begin creating a particle system, you first need to determine how the particle system will operate and what objects it will interact with in the scene. Then, you set up the scene in order to achieve the result you're looking for. This scene contains an architectural fountain with 2 water spouts on the sides of the pool and a sphere in the middle. You will use the mParticle tools to make a realistic simulation of the water in the fountain. In the first step, the water will shoot out of the 2 pillars that are in the pool. Then some of it will bounce off the sphere in the center, while the rest of it will run down the sphere. To accomplish this using the simulation tools available in Particle Flow, you will add a special modifier to 2 objects in the scene. The objects you want to add the modifiers to are the objects that will collide with the particles. The first object will be the sphere in the middle of the pool. The modifier to add is specific to the mParticles that are used for simulation. mParticles use the Mass Effects dynamic simulation system to accurately simulate the motion of the particles. By using this modifier, you are able to incorporate the granite sphere into the simulation of the particles. Select the sphere in the middle of the fountain. In the Command Panel, click the Modify tab. Expand the Modifier List drop-down and choose the P-Flow Collision Shape World Space Modifier. When a particle hits a deflector, there are a number of options to set how it deflects off that object's surface. Using this modifier allows you to assign bounce and friction parameters that will affect the particles. In this example, these parameters will control how the water particles interact with the sphere. There are several parameters that the P-Flow collision shape contains. However, there are 2 primary parameters that dramatically affect how particles interact with the surface. The first one is the restitution amount. This parameter determines how much the particles bounce off of the surface. Restitution determines the percentage of bounciness for the particle when it collides. A high value makes the surface more bouncy, whereas a low value will cause particles to hit the surface and not bounce as much. By changing the restitution amount, you can obtain a realistic effect of water bouncing off of a stone surface. Set the restitution to a value of 0.5. That will set the amount of bounce off of the surface and cause the particles to bounce only a little and skim the surface. The other parameter is friction. This parameter determines how slowly the particles move along the surface. A surface with a higher friction value will cause particles to be more sticky to the surface, and lower values will cause particles to slide more easily along the surface. Keep the friction extremely low. Set the value for the static friction to 0.1. Set the dynamic friction to 0.1 as well. This will allow particles to gently slide along the surface of the sphere. Before activating this modifier, make sure the shape is set to geometry and turn on Smooth Surface. Activating the Smooth Surface option will treat the surface as if it is smooth and not faceted. Once those options are set, click Activate to turn this into an active particle flow simulation object. The other object to add a P-Flow collision shape world space modifier to is the water in the fountain. Even though the particles will not be bouncing off of the water, you want to be able to use this as a way to trigger an event. Click in the Fountain Cam viewport and select the Fountain Water object. Again, add the P-Flow collision shape world space modifier from the Modifier List dropdown. In the P-Flow collision shape modifier parameters, set the shape to plane. Set the restitution value to 0.3. Change the static friction value to 0.1 and the dynamic friction value to 0.1 as well. When you're done, click Activate. Since this is a simulation, you do not need to add any forces such as gravity.